All right, good afternoon, everybody. So this is going to be our review for the test today. I'll take time to go through these questions on the review guide or the review on the board here, and then you guys will take the test for Algebra 2. And again, I'm doing open notes since I've been off and on here, so let's get rolling. So if you need to pause the video to work through all these, please do that. Allow about maybe a minute per question or so. That way we can get through things efficiently. Okay. So starting out, if we are factoring questions like these, so remember, we're looking at these to see if there's anything you can take out. So we have a 25, 20, and a 4, which there's nothing you can take out. So then we're looking at SMILE method here. So we look at breaking down the front number. That 25 would be a 5 and a 5, and break down the back number, 2 and a 2, or we could also have 25 and 1, or 4 and 1. But these are special patterns here. When you see perfect squares like this, so 25 is a perfect square, it's 5 times 5. 4 is a perfect square, that's 2 times 2. Generally, you're going to go with the perfect squares and try that first, okay? Because this would be called a perfect square trinomial. So we have to have the a with the front term, so it would be 5a here, 5a here. And then we said 2 and 2 for the back, so 2 there, 2 there. And then if you wanted to try your SMILE method stuff, you could here. So this would be 10a, and this is 10a to get your signs. Can we use 10a and 10a to get negative 20a? Yes, they both have to be negatives. So we are there, all right? And then a lot of the times you want to check the last term. This doesn't want to erase for me. Okay, I want to check the last two terms to make sure that that gets me this. So negative 2 times negative 2 gets me that positive 4. So this checks out. This is our answer. Okay. A little bit cleaner answer is if you write this like a perfect square, 5a minus 2 squared. This is the best answer that I would like. But again, I'll accept either one of those, okay? This question right here, it doesn't follow the same format as this one because there's not 3 things, there's only 2 things. So you could throw a 0 in the middle if you look that up. That's one way to do that. But again, these are perfect squares. 81 is a perfect square, that's 9 and 9. 36 is a perfect square, that's 6 and 6. So since those are 2 numbers that have to have things taken out, we have to do that first. Or we could take a 9 out of these, okay? So make sure you look to see the most you can take out of those. So if I take a 9 out, I'm going to have 9t squared minus 4. And I still have perfect squares here and here. So this pattern is called difference of squares, all right? It was in the video that was shown before. So I pretty much use the perfect squares of this one. So 3 and 3 for there and 2 and 2 for that, okay? Because those are how we get those perfect squares. So that 9 needs to stay in front. And then the format looks similar to this one up here. We're going to have 3t, 3t, 2, and 2. And then we're going to have a minus for one and a plus for the other. It's always opposite when you're ending up or using perfect squares like this. And I'll show you why this is the way it is here. So if I just look at this piece right here and FOIL it, so that times that, 9t squared, that times that, positive 6t, that times that, negative 6t, and then the back 2 times each other, minus 4. So pay attention to what happens in the middle. Those are opposites, so they cancel. So that's how we knew we should have had opposite signs here. So we get that middle term to cancel, and we have only 2 terms, so it's difference of squares. Okay, that's a fancy pattern. It's not too complicated, but if there's only 2 things, like there are here, you're either going to look to see what you can take out and then call it good, or you're going to use difference of squares to factor that. So this is our answer. Okay. Last one on the bell ringer. All right, so find the missing side lengths of the similar triangles. So we're told that they're similar triangles, so we need missing side lengths. So you got to use the 2 sides that you know in order to find the sides that you don't know. So we know this one is going to match up with this one. So 12 is to 4. That's our proportion for that one. And then we can start getting the other ones. All right, so y is going to be to 8. And then to find y, we cross multiply. So 12 times 8, that's 96. 4 times y, that's 4y. So one-step equation here now, solve by dividing by 4. And you're going to get a 24. So y equals 24. And we don't have any labels, so we'll leave it like that. Okay, that's the way with proportions. Another way you can do it is using a scale factor. So if I look at my 12 and I look at my 4, to get from here to here, I am dividing by 3. Okay, so that means to get from here to here, I'll divide by 3. So x is going to be 6. All right, so either way you do it, I would like you to show a little bit of work, show the scale factor. I think the one on the test might not be a perfect number. I don't remember for sure. If it's not a perfect number, then you're going to have to do it this way because your scale factor is going to be a little bit more difficult to use. Okay? So, next thing you should do today is you should turn in your homework that you had. Okay, so that was your standard deviation questions, and we're going to hit some of those in the review here. So, pause the video quick, turn in your homework. If you've done it already, then keep rolling with the video. So, the first question for the review is this one right here. Okay, and we're going to kind of do 2 different versions of this. So give the domain and range of the relation and then determine if the relation is a function. Write yes or no. All right, so for each one of the questions here, I'll have the sub or have somebody pause the video, or you can pause the video on your own. Give it about 30 seconds and then start the video right back up. If there's 2 questions on a page or a slide that you can work through, I'd work through all the questions on the slide that you can see and then play the video. Okay? So, first one here. Give the domain and range and state if it's a function or not. So, domain we have to write with a capital D, range write with a capital R, and you're going to denote those with curly brackets, and then we're just going to put the numbers in there that go for those. Domain are the x values, okay? And we write them from least to greatest, no repeats. So I'm looking at here, this is an x, this is an x, this is an x, that's an x. So we write the smallest first to biggest, least to greatest. Okay? That set right there contains my x values. Do the same thing with the range, go from smallest to biggest. So -9, 2, 5, 7. Okay? And then how do we determine if this thing is a function? Well, we're looking for repeating x values. If you have an x value that repeats, then it is not a function. Okay, so repeating x values are not good. This we have 9, 8, 1, -1. That is a function. Okay, and generally another way to look is if you have less things in your set of domain values than you do your range values, that means you may have had a repeat. So yes, this is a function. All right, scroll down here. We're going to graph these points on a graph real quick. Let's put that negative where it's supposed to be. And then state whether or not this is a function. Okay? And you don't have to do domain and range. You can do this for practice. Okay? So graph the points. We got our Cartesian coordinate system over here. All right, and I move things around again. So go for this one, left 7, down 3. Which would be left 7, down 3, we land right here. Okay? You don't have to label it, I'm just doing it for you. So -5 up 4, that's the next one. So -5, 4, and then the next one is -1, 3. And then the last point, we have -1, -3 right there. Okay? And there is a way to determine if these things are function or not when you're looking at a graph, okay? If you're looking at the x values here, like I just said in the last one, -7, -5, -1, -1. I see a repeat right there, not a function. Okay? If I'm looking at a graph, hopefully you remember this from previous classes, you have to do a vertical line test. So if I hit 2 points on that vertical line, like I do here, that's not a function. So we shouldn't have x values line up. Okay? And then a function in general is a equation or a relation where if you put one number in, you're going to get another number back out. Only one number back out. You're not going to get multiple numbers back out. We'll just get one number back out. Okay? On to the next thing. Multiplying and factoring. We'll do all four of these at once. So pause the video, have students work through all four, look for about 2 to 3 minutes, and then start up again. Okay, so multiplying for C and D. These are binomial pairs. Okay, that's a binomial, that's a binomial. We're foiling here. To multiply this stuff, you use FOIL method. FOIL stands for first, outer, inner, last, FOIL. Okay, hopefully you remember that. Let's see how to do it. So I take this times this, b squared, this times this, positive 6b, this times this, positive 3b, this times this, positive 18. That's my first, outer, inner, last. That's the progression there. Okay, and then you got to finish this up by combining like terms. You have a couple terms right there you can put together. So b squared plus 9b plus 18. Okay, same thing for D. So we do first, 4p squared, outer, negative 8p, inner, positive 3p, last, negative 6. Combine those two in the middle, 4p squared minus 5p minus 6, and we are done. All right. And then factoring these ones, and I see two more down here, so we'll pause again to get those in a minute. Let's take care of the two that I asked you to already. So right here I got two things. I know earlier on I said that a lot of the times when you only have two things, you're going to be doing difference of squares, but I mentioned doing something before difference of squares. You look and see if you can take things out. If I can take something out and we don't have difference of perfect squares anymore, then you're just using greatest common factor. So between this and this, I can take out a 5b. And then I'm left with b plus 9. So that is done. I can't go any more from there because there's no squares in here. All right. Now over here, we're doing reverse FOIL. You could kind of treat this like SMILE method if you want to. But the thought process is what two numbers multiply to this and add to this. So you could list all your factors if you wanted to. 3 and 10, 5 and 6, 30 and 1, 15 and 2. But it's kind of a waste of time. You should be able to do this in your head. Which combination over here adds to 11? It's going to be 5 and 6. So we set it up, make it look like a FOIL. X is in the front, and then 5 in the back of one, 6 in the back of the other. And everything's positive here, so everything's positive here. Okay? It doesn't matter if I have x plus 6 and then x plus 5. It's the same thing by commutative property of multiplication. All right. A couple more here at the end. We'll just kind of work through these together rather than pausing the video. Okay. This one right here, two things. So that, and I see that they're perfect squares. Can I take something out right away? No, because this would, the only thing that comes out of here is 5. Or 25, I suppose. And the only thing that would come out of here, I guess there's more things coming out of this, but not a 5. Okay? So this is a perfect square. So I'm going to have 9b in the front. Oh, shoot. This is the perfect square. So I'm going to have 6b in the front of both my parentheses. And I'll have 5 in the back, because 5 times 5 gives me 25. And then remember with this pattern, one of these has to be a positive, one of these has to be a negative. Gosh, I did it again. One of these has to be a positive, one of these has to be a negative. Okay? And that's my difference of squares pattern. H is the SMILE method, and I know that it's SMILE method because I don't see a perfect square back here, so I can't use that easy method I showed you before, and I got a number in front, okay, which we list our factors of our front number, and then we start guessing and checking to see if we can get it right. So the back one also 7 and 1, and then we start trying things, okay? And you might be doing the 4 and 1 first. I like to do the smaller combination first to see if we can get our answer. So 2x and 2x, Okay, and then the back is a 7 and a 1. It doesn't matter where we put that because we're going to check it anyways to see if it works out. So check it with a smile. 14x. Check that. 2x. Can I use 14x and 2x to get 16 in the middle? Yeah, that combination works if I just keep them positive. So those are both positives, and then we got it right. Okay, I didn't mention earlier on, if you wanted to check every single one of your factoring, what you could do is just FOIL this back out, that times that, that times that, that times that, that times that, and you should end up back where you started. You can check your answers on factoring. Okay? So similar shapes again. We got similar shapes, and then we got a standard deviation. All right? So the pair of rectangles is similar. Find the missing value. So looking from this one to this one, if I try to do the quick way using a scale factor, it's not a perfect scale factor. Okay, it's going to be a decimal. So we're going to use our proportions. So big to little, 99 to 45, and then 44 to x. And then we'll cross multiply and get our answer from there. So that would be 99x. I'll do it inside our rectangle over here. And then 45 times 44 is 1980. And then we got to divide those out. So divide by 99, and you get x equals 20. That kind of works out to a nice number there. All right? And you could figure out your scale factor here, 99 divided by 45, and figure out what happens, see what the number is, which we could do that here quick. Okay, so it's 2.2. So if I took this and I divided it by 2.2, I should end up at that, if you wanted to check it using your scale factor. Okay? For this one, we are told, well, I guess it doesn't say this is a right triangle, but we're going to assume that this is a right triangle because I want you to use Pythagorean theorem. Okay? We have A is 8, B is unknown, and C is 28. So if you want to draw yourself a picture, that's fine. That's not a great triangle, but we'll go with it. And we have 8x, 28. So we got to solve for x using Pythagorean's theorem. Okay? So it's going to be 8 squared, 64. X squared equals 28 squared, which is 784. All right. Now we got a couple steps to do to solve this. So move the 64 over. All right, let's get that out of the way. So x squared equals 720, and then we have to square root both sides to get rid of that x squared. So we get x equals 26.83. If it doesn't say how many places to round to, go to the second place. That's kind of standard for me in my Algebra 2 classes. Okay, so we got mean, median, mode, and then we have standard deviation. We got range on this one too. So I would have you pause the video on this one, work through these, compare answers, go through it real quick for the answers, all right? So we got to write these from least to greatest. So 6, 6, 7, got that, got that, got that. We got a 10, 13, 24, 26, 35. So we got all of those. So we have a total of 3, 6, 7, 8 numbers. So when we do our average, we're going to divide by 8. But let's do the easy ones first. So median, we look for the middle between these. So you could cross off each one out here and then kind of work to the middle. And it looks like our median is going to end up somewhere in here. So we do 10 plus 13 divided by 2, you're going to get 11.5. Okay, so the median is 11.5. Range, we do largest number minus smallest number. So 35 minus 6 is a 29. Okay, and then the one that takes a little bit more time, the mean, remember we add them all up, divide by how many you have. So let's add those all up here. And we get a grand total of 127 for these numbers. And like I said before, we have 8 numbers, so we divide this by 8, and that's going to get us our average, or our mean, which is 15.875, but I said I like 2, so we'll go 15.88. Okay? That's what we're looking for. And I just finished reading the directions that says around to the 10th. I'm going to keep going with what I like to do and just keep it at 2 decimal places for this. So let's go with that. So standard deviation, I'm giving you 5 numbers here. Okay, so we need range, variance, of standard deviation of the data to the nearest 10th. We'll go with the 10th this time since I read the directions all the way through, right? So we have to make a table. We have to make a chart, all right? And the chart will be given to you on the test. So we start with the first column is X, which those are the numbers that were given, okay? So we got 60, 60, and I want to write them out as many times as I see them here. 75, 75, and 100, okay? Then this column is X minus X bar, okay? Hopefully you remember what X bar is because it's something unique you haven't heard before. X bar is the mean. And we're going to calculate that and kind of have it up to the top there so we can use it when we need it, all right? So then this one is X minus X bar squared. So remember this column, we take these values and square them, but when we did it in class, we just kind of got this number, squared it, then we got that number. So we just kind of did a whole row at a time to be efficient with our time, okay? So average, we got 60 plus 60 plus 75 plus 75 plus 100. And that gives us a total of 370 divided by how many things we have, which is 5. So our average is 74. Okay? That's a fairly nice number to work with. So now we're going to subtract 74 from all these and square those numbers. So 60 minus 74 is a negative 14. Negative 14 squared, 196. Okay? Same thing here, negative 14, 196, and then we got 75 minus 74, which is a 1. That'll just be a 1 here. Same thing here, 1, 1. And then 100 minus 74 is 26. So 26 squared is 676. Okay? After we get to this point, we needed to make a new average with this column right here. All right, we need to get a new average, but remember you divide by 1 less. So let's total this up. And I get 1,070. When I add these up, there's 5 numbers, so I'm going to divide by 4. And I get 267.5. Okay? That number right there is called the variance. So remember I talked about this letter. It's sigma. Variance is sigma squared. Okay? So sigma squared equals 267.5. And then we have to get to sigma, which is my standard deviation, by square rooting that number. So if I square root that number, you get 16.355. And we said to go to the 10th, so 16.4. Okay? This is the number that you're looking for in the end. That's the standard deviation, which tells us how far all of our data points are from the average. Okay? And our average is 74. So remember, if we went about 16 and a half up and down from 74, we should hit most of our data points. Okay? Which we do. All right? So that is your review. And now it's time for the test. So that's what we're working on right now. This is a smaller than normal test. It's a front and back of a page. My tests are usually front and back of 2 pages, just so you're aware. So you're allowed to use all of your notes on this, but you cannot use any Google or phone or anything like that. Okay? So good luck.